Hello guys, welcome back for the new video. In the last video we managed to solve the day 4 part 1, so in this video let's continue from that. Let's jump into the part 2 and see what kind of challenge we have waiting for us there. But without further ado, let's reconnect the runtime and then jump back to the code. So in part 2, in part 1 we needed to figure out how many times the Xmas word was appearing in the matrix. So let's see what we have now. The elf looks quizzically at you. Did you misunderstand the assignment? Looking for instructions, you flip over the word search to find that this isn't actually Xmas puzzle. It's an Xmas puzzle. So dash here, in which you are supposed to find two mass in the shape of an X. One way to achieve that is like this. Okay. Okay. So we need to do a bit of a tweaking. So the example is same as we have here. Here, yes, 9 times. Okay, flip the word search from the instruction. Yes. So the input is the same. So we need to just find the good mass combinations, should I say. Just run these so everything is, of course. Yes, looking good. Maybe we could start with cleaning up the implementation that we did for the part 1. We can remove that print at least. And basically these calculate locations ended up to be something that we didn't need. So we can remove that one. This approach that we ended up implementing in the end is actually quite simple and straightforward. So basically what we want to do is that now we are not interested in X, but we are interested in how this actually, now when we think about this, how should we approach this? Because there is a couple of ways. We can find all the words MAS and then figure out if the A is in the same location. So the challenge was how many times does Xmas appear? So how many times we have this kind of happening? Okay. So technically, if we would find all the words mass, and then every time we find new mass, we will keep count how many, or what is the location of A. So if the A is matching with two or there is shared location between two mass words, then we know that those must be crossing. And of course we need to limit out the words that are going vertically and horizontally. Okay. So let's actually start by creating or let's actually first run this and then this. I forgot to run this, of course. Now it should be, yes. So that still works after the cleanup. So let's start new section. Day 4 part to, did I set a code? Yeah, I did. So what we want to do is first, maybe we could start with this same kind of approach. We want to find all M char locations. Yes, there is 10,846. Oh, actually, we need to update these as well. Yeah. Anyways, the okay, 7,110. That's good. And then we can copy this approach so we can adjust it a bit. So we know that this location is M character, and find char from position. This is something that we want to modify as well. The difference here, what we want or change what we want to do is that because previously we checked all the directions, we want to only check the diagonal position. So basically, from the current char location, we want to check the positions where both of x and y are modified, basically. So this does not fulfill the need requirements. Then this does not either. Neither does this. This does. Both are modified. This does not. And this does. Okay, so now we check only the 4 positions. So this is cool, correct. And then the rest, if the char location is set, then we check only that. That is very good. And we want to check the A character position. This is important. And then we want to check the S character position. Yes. And then let's update these, and A character pos char pos. Then yes, that is A character, or actually it is the S. Oops. And now we have that one. Yes. There is some left over still that needs to be replaced. or actually, we are not actually interested in the sense this, I think. Or we are on that, but not on this, okay? So we know that there is now mass word in the matrix. So we first check, we know that location is M, then we try to locate A. It can be anywhere around the diagonal axes. And then if we have an A, we will loop the positions through. And then for every A, we try to find S. If we find S, then then we know that this is mass word, and then based on that, we previously just increased the counter, but now we want to do so that we will keep a dictionary, so A locations, and then maybe actually it could be a list of tuples, and then since we have the A character position here, or actually here, we can check that if A char pos in A locations, then we will increase the counter, and else we just A locations append A char pos. So if it is not found from the list, then we will add it to the list. If it is in the list, then we can just increase the counter. Let's see actually, will it run? So we have that one already executed, then the update find character from the position, and then maybe we could actually change the name a bit, find character from position. Let's just add number 2 there, so we can easily see the difference. Not really good naming practice, but whatever. Let's see how many we did get. So 1935. We could already try this out. Not the right answer. Your answer is too high. Okay, so it's lower than that. Okay. Good to know. We have some bug in the system or in the code. So then let's start to check out or approach via this manipulated input, which we use to debug our previous part as well. Yes, that's looking good and correct. How about if we try this one? So it would be 1 and 1. Okay, it did not locate anything. Okay, we have already one issue which I didn't realize. Let's actually see now if let's actually run this once more. Okay, we have still 0. Interesting. And then if we will get does it find any 8 character positions? Okay, yeah, it makes sense that we don't have any actually here. Let's actually see that if we would make this, or we actually have, but the second M location is not listed here. So if we would have, this is 1 and 3. Let's actually see. Okay, now, so it could even work. I'm quite confident now that this could even work. So let's just try and see. So we got lower answer, 1815. Let's try that one. Okay. So just logical error that we used wrong variable name, in the sense caused by the fact that I just copy paste blindly the previous days or the previous part code. Okay, that was straightforward. Then we can already continue with the day 5, part 1. Let's see what we have there. Print Q, satisfied with their search on Sears, the squadron of scholars suggest subsequently scanning the stationary stacks of Subspace 17. The North Pole printing department is busier than ever this close to Christmas, and while the historians continue their research of this historically significant facility, an elf operating a very familiar printer beckons you over. The elf must recognize you, because they waste no time explaining that the News Lake launch safety manual updates won't print correctly. Failure to update the safety manuals would be dire indeed, so you offer your service. Safety protocols clearly indicate that the new pages for the safety manuals must be printed in very specific order. The notation XY means that if both page numbers X and number Y are to be produced as part of the update, page number X must be printed at some point before page number Y. The elf has for you both the page ordering rules and the pages to produce in each update. Your puzzle input, okay. But can't figure out whether each update has the pages in right order. Okay. The first section specifies page ordering rules. 1 per line. The first rule 4753 means that if an update includes both page number 47 and page number 53, then the page number 47 must be printed at some point before page number 53, okay? 47 does not necessarily need to be immediately before 53. All the pages are allowed to be between them. That is clear. The second section specifies the page numbers of each update. Because most safety manuals are different, the pages needed in updates are different too. The first update, 75, 47, 61, 53, 29, means that the update consists of page numbers. So they have page numbers, yes. To get the printer going as soon as possible, start by identifying which updates are already in the right order. In the above example, the first update is in the right order. It's correctly first because the rules to put. Okay, yes, it's correctly because the first update does not include some page numbers, the ordering rules involving those missing page numbers are ignored. So if rules without those numbers are not applied, okay, that's clear. The second and third updates are also in the correct order according to the rules. Like the first update, they are also do not include every page number, and so only some of the ordering rules apply within each update. The ordering rules that involve missing page numbers are not used. Okay, in fifth, not. Okay, yes, makes sense. The last update is not either. For some reason, the elves also need to know the middle page number of each update being printed, because you are currently only printing the correctly ordered updates. You will need to find the middle page number of each correctly ordered update. In the above example, the correct orders updates are okay. These have middle page numbers of 61, 53, and 29 respectively. Adding these page numbers together gives 143. Of course, you will need to be careful. The actual list of page ordering rules is bigger and more complicated than the above example. Determining which updates are already in the correct order. What do you get if you add up the middle page number from those correctly ordered updates? Okay, let's get our puzzle input. Okay, so these are the rules and then these are the updates. Let's split this up so that we will have the rules. So we have rules of this, and then we have the updates, which are then in the bottom. Okay. And we can already say that to ease up the work, we can split these up by the line change. So we will manage lists like this. So we have lists available, and let's see how long lists we have. So when rules, and then we can have the same for updates. And then if we run it, we have 1176 rules and 192 updates. Okay, this is clear. So we need to somehow know that first check the rules that should be applied, and then we can per row check that is each of those rules complying with all those rules or not. Okay, let's start with that actually. I think that could be a good approach. At least just to get an idea that what we would need to do. So basically we want to, because these rules, yeah, are applied for every row, so we just row or loop through every update. For update in updates, we will have update is a string in this case, and then we just do update. So basically update in this case is update dot split. We want to split it with comma. And I think now I'm wondering, should we do some modification for the rules already, because this format is not necessarily the best. So we could do, let's say here, just update the rules to be rule dot split, and then we want to split it from the pipe operand rule in rules. So what this does, it makes us a list of lists, and each sublist contains one rule. So we can then more easily do so that that when we try to find the applicable rules, we can do so that I think this is something that we could do with this array operator. So basically what we want to do is to check if the given rules numbers exist in update. So basically for rule in rules, if all or maybe in this case, because you know that it's rule contains two numbers, we can just check that if rule 0 in update and rule index 1 in update, then we will have the rule in the list. So now we should have more limited subset of the rules that are applicable, and then we just brute force this through. So what we want to do is now loop through the rules for rule in rules, then get the first rule position, and then or first rule position in the update. So update was there index? Do we have any kind of index value start? I think this could be the one. So if we are just checking that, and then let's copy that one, and then like this. And basically if position 1 is lower than position 2, we are good, and this is valid row. If pos 1 is smaller than pos 2, then this is valid. And was it so that we need to find all the middle page numbers from the updates that are correct. Okay. So we want to have a list mid-page numbers. And then if this is true, then we just append mid-page numbers. So basically it is page numbers. And then append update. We want to access the middle number, so it is something around, if we get for first the length of update and then divide it by half, and then I think we in Python we have round a number to given precision in decimals. The return value is integer if n digits is omitted or none. Otherwise, the return value. Okay, let's actually check. So if we have 9 pages, the midpoint is 4.5. Okay, so it's rounding down, which is in the sense fine. We just need to know that, so we can add the +1 there. Or no. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Yeah, exactly. Exactly like that. So we want to get the mid. Yeah, of course. Or is it actually, if we think about it, accessing the index? So actually this is correct, I think. We can try this out just to make sure. And I don't need to then investigate that in that detail, that why this is not working. If we just first test it and then see how it behaves. It should say 72. Yes, correct. That's perfect. That's perfect. Okay, let's then just run this, and preferably let's also print the mid page numbers. Oh yes. Okay, interesting. 6 is not in the list. That is very correct. I should have used the applicable rules. Okay, none. Interesting. I'm slightly suspicious about that. But let's see what kind of numbers we have. So applicable rules is empty. Question mark. This is so slow, this for some reason. Okay, yeah, so it is empty. Every time. Okay, interesting. Maybe I have some issue. Maybe I have some issue with this. So rules in rule, if rule 1 in update and rule 2 in update. Let's try it now if it... Okay, it was just kind of splitting it up differently. Mid-page numbers. So we have quite few. Slightly suspicious that why we actually could just cast these to integers, because if we try to sum them up, it will ease up. So if we just, let's check the length. And then let's check the sum. This is getting very slow. I don't know exactly why. Maybe I need to reload the page. So now it should give it the length and sum of the numbers. Okay. Does it make sense? No. No, it does not. Because we have mistake here. So if all actually we can then do it like this. And then if this is not correct, so position 1 should be always smaller than position 2. We can then just say break. Yeah, I'll now try to reload this. Maybe it helps. Maybe it helps a bit on the... Let's see now. So we need to have all the rules applicables, or like every update needs to apply for every rule. So what we want to do is that we can have it's applicable and set it to true, and then we can set here that it's applicable false, and then down here we can check that if is applicable. Why is applicable? And then do it like this. Maybe is applicable is not good naming, but it should give us an idea. We could even optimize this a bit and break here. So we don't need to loop all the rules through that we have. So now we have 85 mid-page numbers which sum up to 4991. We could try that out. That's not right, and your answer is too high. Okay, interesting. Maybe we missed something. And we are still looping through all. Rerun this. And then we can run this. And does it change the... No, good. So what is the problem here? So we loop through the rules and try to find the applicable ones. Let's quickly skim through the guide or this rules that we were given. So if any update includes both number 47 and 43, then the page number 47 must be printed at some point before page number 53. Makes sense. The second section specifies the page numbers of each update. Okay. Actually, we could check here that since there is only 85 of those numbers or like rows that are good, we could just get the length of every row just to get understanding that is there some like edge case or something that we are not tackling here correctly. So there every page number is uneven, which is correct. And what did I need to do? These numbers, actually the page ordering rules is bigger and more complicated than the above. Determine which updates are already in correct order. What do you get if you add up the middle page number from those correctly ordered? Okay. So it is something with this then. Or actually, yeah. We get the update and then we would print the rules associated to that update. Let's see what does it say or how does it look. Okay, so example in this case 76 needs to be before 38. That is true, and then 62 before 56. Okay, and then maybe we could print the mid number as well, and then we could, didn't it copy it? Yes. Then let's add one print here as well, just to clean up the prints a bit. And then let's run it. It says that the mid number is 95, which 5, 6, 7, 8, 9, 10, 11, 12. Good. And then 3, 4, 5, 6, 7, 8, 9, 10. Aha. Interesting. Actually, I'm now feeling that do I have a bug? I think I do. If we have that array, yeah, I was kind of thinking that this can be slightly problematic, this bit number 95. And if I will get the index of index of 95, and then if we get the length, I think I need to just minus one from the after the rounding, but yeah, its length is 23, so it should be 11. Yes. So with minus one, we will get the correct result. Yes, let's try with that. So we will, after rounding, we will get the minus one. Yes. This should bring the result down a bit. Yeah. 4922. That's not the right answer. Your answer is too high. Still too high. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now this is correct. So now I'm wondering that what happens if there is no applicable rules? Because the first operator does not have included some pages, but the ordering rules involved those missing are ignored. The second and third page, it's update the ordering rules. Okay. Okay, so they are applicable if there is no rules. Okay. And these are good. And we can even remove these or put them in multi-line comment. And we can run this. Looks good. Let's do one test still. Now I'm wondering, is this breaking the correct here? Actually, let's add the update as well. So we can see that is it so every time it hits that one, it's different. Okay, Okay, and these are good. Then it sets this false. Let's try it like this. Let's try it like this. Does it make a difference into the? It is definitely slower, but same answer. So that break was good to have. Now I'm kind of wondering that okay, it has offloaded there. I'm like slightly wondering that do we have everything in account? Did I copy the whole input and the output? Input seems to be like it ends with row 2029 892 and then starts with 1162 38 56. Okay, and then this ends 1493 and it starts with 6622. Interesting. Okay. So we know that this is good. The input, I mean. And or inputs. And how I'm wondering is there now something with this? Shouldn't be. Because it's both are, as we can see, everything is strings, so it should be able to compare those and get the positions. And then, but so if 85 is, and it says that we need to sum them up. Somehow like, I don't know what is the issue now. What is the issue? And then I'm just wondering that if we calculate this here as well, like in the same way as we do same way as we do with the cool. I'm wondering also, is this editor now like somehow playing with us? And then if it's the print page number from, let's in there. So something with this. I'm wondering that how many applicable rules we have. So we have overall 1176 applicable rules. So I'm wondering that are we now somehow like So we never exceed really 200 or something. Okay. Now I'm started to wonder that if we split them up here, will the list order stay? We actually could check that one. Instead of printing this, we could just check that if the rule can be found in the rules, or sorry, in the original rules. Of course, we don't have that anymore. Maybe we will just do so that we will update these to be modified rules. So we know that it's somehow like manipulated. And we can here as well run this again. So now we have that one, that variable overwritten. Now we just do this, yeah. And now we will update the modified rules to here. And I was thinking that we could check that if we can find this rule, just to rule out that there is no chance that any of these rules would be kind of wrong. If they are, then we have an issue. I think actually we might want to do it just this in rules. So this should be kind of the line in the original rules after splitting. And then if we see that T is false, we can print the rule and then this yeah, maybe this is actually the one that we could print, so we can see already quite fast then that what is actually going on. Okay, no cases were found, so every rule was found from the interesting. But yeah, I think it's good to pause here, since the video is also starting to get quite long. So let's continue in the next video. Thank you for watching. See you guys next time. See ya.